This is the first video for the electricity and magnetism unit, and it addresses the topic of charge. By the end of this video, I'd like you to be able to know the two types of charged particles, understand how an ion and an object become charged, know the unit of charge and how it is defined, understand what is meant by the elementary unit of charge, and understand the qualitative relationship of force and charge. So where does charge come from? Well, inside the nucleus, or inside an atom, there are three kinds of particles. There are electrons, which are negative, there are protons, which are positive, and there are neutrons, which have no charge or are neutral. Both the negative electrons and the positive protons have the same magnitude of charge, so they have the same amount of charge, but opposite. And the charge of the atom is going to be determined by the balance of the protons and the electrons. If you have more electrons than protons, you're going to form a negative, and we call charged atoms ions, and this is a specific kind of ion called an anion. If you have more protons than electrons, you're going to form a positive ion, which is called a cation. And if you have an equal number of protons and electrons, you're going to have no charge. An object becomes charged in a similar way that the atom became charged, by giving electrons up or gaining electrons. So a good example of an object that becomes charged is a balloon when you rub it on your hair. When you rub a balloon on your hair, what happens is the electrons from your hair are transferred to the balloon. If you rub the balloon on your hair enough times, many electrons get transferred to the balloon, so the balloon becomes negatively charged. Because your hair gave up these electrons, it becomes more positively charged. And because it becomes negatively and positively charged, those electrons and protons want to meet each other once again, and so your hair is attracted to the balloon, which is now charged. So how do we measure the amount of charge that we're dealing with? We measure the amount of charge using units called coulombs, which we abbreviate with a capital letter C. We define the coulomb as the charge transported by a current of 1 ampere in 1 second. Because we define it because it's defined by a different unit, the ampere, and a second, it is a derived unit, and because charge has no direction, it is a scalar quantity. So 1 coulomb of charge doesn't represent the charge of an electron or a proton. It in fact represents the charge of 1 coulomb represents the charge of 6.25 times 10 to the 18 electrons or protons. If we flip this around, we would say that 1 electron or 1 proton has a charge of 1.6 times 10 to the minus 19 coulombs. Because both the electron and the proton have the same charge, but opposite, we call 1.6 times 10 to the minus 19 coulombs the elementary unit of charge, which we represent with a lowercase letter e. You might see the elementary unit of charge prop up in some of your questions. For example, an alpha particle has an elementary charge of 2e. So I would say, for example, 1. And since it's equal to 2e, that means it has a charge of 2 times the elementary unit of charge. So it would be 2 times 1.6 times 10 to the minus 19, which is 3.2 times 10 to the minus 19 coulombs. Now 1 coulomb represents a lot of charge. So for example, 1 coulomb of charge is 15 coulombs of charge is transferred when lightning strikes the Earth. So 15 coulombs of charge is transferred from the clouds to the Earth. If we look at something like a AA battery, they contain 9,000 coulombs of charge, which is shocking considering that a lightning strike sounds way more powerful than a AA battery. That just means that it's the rate of transfer of these charges and the amount of charge we have to take into consideration. And most of the quantities you're going to be dealing with, so you need to watch out for units on the questions you're going to be asked. are going to be in the range of 1 picocoulomb to 1 nanocoulomb. So you might see charges like this when you have static electricity, for example, when you comb your hair. Lastly, what is the relationship between charge and force? So there's 4 things that can affect the amount of force a charge exerts on another charge. And that is the type of charge, the amount of charge, distance between the charges, and the medium or the environment the 2 charges are in. So the type of charge refers to whether or not the charge is positive or negative. So if you have a positive and a negative charge, the force between them will be attractive. They'll want to pull toward each other. If you have 2 like charges, 2 positive charges or 2 negative charges, the force between them will want to repel. The amount of charge refers to how many coulombs of charge you would have. So if you have 1 coulomb of charge, you'll have less force between 2 1 coulomb charges than you would between 2 coulomb charges. The force becomes weaker as the 2 charges go apart from each other, and depending on the medium, it will either strengthen or weaken the force between the charges. All right, that's all. Thank you.